In this video, I'm going to show you that adding an infinite amount of numbers together is dependent on the order in which you add them. Now, if you have finitely many numbers, when you add them together, the order in which you do this does not matter. 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. But that's not the case with infinity. To show you this, I'm going to take this infinite sum here. Normally, we call this the natural logarithm of 2, but that's a scary name. For now, let's just call it Bob. Okay, now I'm going to rearrange the terms that make up Bob. I'm going to do this in the following way. If I see a even number here on the bottom, I'm just going to leave this term in its current position. If I see an odd number, on the contrary, I'm going to move it a little further along in the sum to put it right in front of where I would find the number that is twice as big. So for instance, 1/3 would go in front of 1/6, and 1/7 would go in front of 1/14. So this is how it goes. Let's do it. 1, okay, that's an odd number, so we have to put it in front of 1/2. But it's already in place, so let's just do that. 1/2, well, that's an even number, so it doesn't move. 1/3, okay, so I have to move that in front of 1/6. So let me keep it for now, and I'll put it in when it's necessary. 1/4, okay, that's even, it stays there. 1/5, okay, gotta move it in front of 1/10. Okay, 1/6, that's even, okay, but first I have to put 1/3 in front of it, okay. So then I continue 1/7, etc., etc. You can see how this goes. Okay, now that I have this new sum here, I'm going to do very simple operations on it. The first is I'm going to combine some of the terms. Okay, so here 1 minus 1/2 is equal to 1/2. Okay. 1/4, I'll just rewrite that. 1/3 minus 1/6 is equal to 1/6, because 1/3 is actually 2/6. So 2/6 minus 1/6 is equal to 1/6. God, that's hard to say. Okay, I'm going to continue along like that. Okay, here's the result. Now that I have this result, I will factor in 1/2. So I'm gonna put 1/2 in the front, and then put the rest in parentheses. Okay, you can see that this is still equal to this. If you redistribute 1/2 into the parentheses, you'll get the original sum. Okay, but now let's look at this. What's in this parentheses? Well, that's Bob. Okay, so this is actually equal to 1/2 of Bob. So you can see that just by rearranging the terms of Bob, suddenly he's only half the man that he used to be. Now, why is that? You can see, if you look closely at the sum before and after I rearrange it, that in the first sum, we have one positive number, one negative number, one positive number, one negative number. But after I rearrange it, suddenly I have one positive number, two negative numbers, one positive, two negative, meaning that I have actually pushed all the positive numbers away, and although I didn't take any of them out, they are now less likely to show up, they now constitute only 1/3 of the sum, whereas before they were 1/2. And so they are less dense in this sum. So since we have less positive numbers, well, we don't actually have less of them, we have the same amount, but they show up less often, well, then the result is a little smaller. So I would like to leave you with an image to try and understand this fact, which is the following. If you have a rug on the floor and you take one of the ends and you flip it, you will see a ripple travel through the rug. Okay. And when the ripple comes to the end of the rug, it just slams on the ground, and the rug is in the same position as it was before you shook it. But if now this rug is infinitely long, then when you shake it, the ripple will just travel along the rug, and since it has no end, it will just never stop. Okay, if there's no friction and no loss of energy, but you get the idea. And so the rug essentially will never come back to its original state where it was perfectly flat on the ground. So that's more or less the same thing with infinite sums. You can see that here I was able to make a transformation to this sum that only worked because the sum was infinite. If the sum was finite, then there would have come a point where I couldn't take a number and place it further along. But since the sum is infinite, I can keep doing that. And that's why, essentially, I've changed the state of this sum. And that's why it doesn't work when you only have a finite sum. Thank you for watching.